alive.
Is that it?
Hi and welcome to Extronical. This is part three of the Space Invaders project. Today we're going to move on to animating and moving the invaders. So first of all, we'll show you what the actual end code will achieve. So if you look on the screen now, let's bring that up. We've got the previous example where we left off with just an array of static invaders, and if we go forward and we just upload the new code, so compiling, and hopefully very shortly uploading. It's been a little laggy than usual. Still compiling. It's not that long a project. Nearly there. Come on. Okay, so uploading. And there we go. So as you can see, they're no longer static, they're moving across to the right hand side of the screen, fully animated. When they get to the right hand side of the screen, they drop and start moving back to the left. And again, if you're watching a second, when they get to that side, they'll drop again and go backwards and forwards like that, dropping a little bit each time, just like the original arcade did. And with each movement, you can see the different animations that are happening for each invader. They're basically just two animations, two walking frames, and we flip between one or the other on each movement that it does. Okay, so bringing that back off screen, we'll have a look at the code that achieves that. We'll start off with two extra lines we've done here on line 16 and 17 here. We've got the setting for how much the invaders drop by in pixels. So every time they get to one side of the screen, right or left, they will drop by this amount. In the moment I've got it set to 4, seems about right for the screen. And then the next one is the speed of movement, so how fast they go across the screen. So the lower the faster, which sounds kind of counterintuitive. You think of higher numbers meaning higher speed. In this case, it's just makes it a lot easier for the programming. In fact, if I sort of we saw the speed before, if I drop that to say 4, so it's about a third of the speed, and we'll upload that, and we'll bring the back on screen, so it's uploading now. You can see they've just nearly got to the bottom. And we'll just compare the speeds that they move across now. So quite significantly faster, certainly uncomfortably fast. And obviously as this game progresses, when you shoot more aliens, they do get faster, but their speed is directly related to change that back to 12. I'm going to take that off screen now as well. Their speed is directly related to how many aliens is on screen on the actual display. If you read on the history of Space Invaders, that was not an initial intention. It was just the byproduct of the fact that the process technology at the time wasn't very good, wasn't very fast, and that as it had to deal with less aliens on screen, it had less work to do, so it actually did it faster. But then it turned out to be a really good game mechanic. So we've got those two, and if we look down, scroll down the screen, we've got more graphics on. So we've got Invader Top Graphics and Invader Top Graphics 2. These are the two frames of animation for the very top invader. And then we've got the middle graphics and the middle graphics 2. So all I've done with the naming convention, I've just put a 2 on for the extra frame animation. And again, we've got the bottom invader, etc. Then we come to the game structures, which we talked about a little last time as well. We've got X and Y, and then we've added on a new one, which is status. So the status means, well, you can see what I'm predicting there. Status 0, if that was set to 0, mean it's an active invader walking across the screen, doing what it does. If it's got a code of 1, it's currently exploding, blowing up. If it's got a code of 2, it's been destroyed and is not displayed. So that's for later, but we do need the status sort of building in now, ready for an episode or two's time. So that was actually the only change really we've done to that. To support that, I've just scroll back up. When I'm talking about active, I've set a constant up somewhere up here. There it is. So line 20, we've defined active to be that 0. We'll scroll back down. We've done the graphics. We have the animation frame here. So we'll just have a quick look at this line. We've got 3 lines that kind of need explaining here a little bit. We'll start off with the bottom line, which is the animation frame, and it's a boolean. It can only be true or false. We've only got 2 frames of animation, so depending on what the state of this is, whether it's true or false, depends on which frame of animation for all the invaders are displayed. So I think if it's false, it displays the original graphic we created in the last episode. If it's true, it displays the slightly changed one, and that's about it. We'll go through later where this is actually toggled, swap from true or false on every sort of like walking out that the Space Invaders do. We've got the alien X move amount, so how much the aliens move per step. So every step they make, they move 2 pixels. This is not set as a constant or a define. We want to be able to change this. We want to be able to change this so that as they get faster, they speed up. Because as I said, on the old arcade game, it was a mechanic created by the fact the processor was quite slow, that it could go moving faster the less aliens are on screen. We've actually got a really fast processor compared to the one that was in the original arcade cabinet. So we need to tweak with these numbers to make things move a little bit faster. So if we make it, say, go 4 pixels at a time, it would appear to go faster, which is a technique we'll use later on in a future episode when we come to look at the mechanic of speeding up the aliens. The move counter is directly, so this one, I'll just highlight for you, this one is directly linked to this invader's speed. So initially, whenever you get a new screen up on the display, a new set of aliens, or they're non-destroyed or anything, invaders move counter will basically be set to 12, and then that counts down, and every time it gets to less than 0, we move the invaders. So it's like doing every 12 cycles of the actual Arduino displaying on the display, it moves the invaders. And again, we'll talk about that in a little time as well. So we'll go to the main loop, and it's been slightly updated. We had a display before, and now we've got something called physics. And physics is basically just the game logic, rules, etc. It's where all your sort of code will go that's deciding if something's been hit, when you're moving something, etc. And all that's in the physics function at the moment is just the alien control, or the alien physics. And if we move on down, it's here. So this is the alien control, and we don't do an awful lot in here apart from loop round all the invaders, updating their position. However, if we look, we'll just scroll it up a little bit, get that right. This is where we're subtracting 1 from that invaders move counter we just mentioned a minute ago. So initially that would be 12 on a new level. We subtract 1 from it, which is what that bit in the middle is doing. Invaders move counter minus minus. It's taking 1 away from it. So if it's 12, it will subtract 1 and store that new result of 11 back in the invaders move counter variable. And after it's done that, we then make a check. Is it less than 0? If it's not, which for a lot of the time it won't, it does nothing else. It comes straight out of the routine. So it's not going to do anything until it gets less than 12. So it's every 12 cycles of displaying something on the screen, we actually decide to move the aliens. So if it does go below 0, then we come to this routine. First line, we've got a boolean set up saying have they dropped, which basically means have they got to a right hand edge or a left hand edge, and that decision is made here. So this rather long line here is saying are we at the edge of a screen, either right or left. The right hand side is decided by this bit. So if we're at the right hand side, this bit will return true. If we're at the left hand side, this bit will return true. And obviously in the middle we've got the OR operator. So if either one of those is true, we then go on to do this code. So if we look here at the rightmost pos is a routine we'll talk about in a minute, which basically scans the aliens, finds the X position of the rightmost alien, we then add this on, and if it's more than the screen width, so if it's more than that 1/28 of this screen, then we've reached the screen edge and we need to drop them. So we'll then go into this code here. If this bit, so the leftmost position, so again we've got a routine we're going to talk about in a second. If the leftmost position, so it scans all the aliens, look for the most left positioned alien. If that with the X movement amount on is less than 0, then again we're dropping. So if we are dropping, then we'll put dropped equals true, and the alien X movement is equal to the minus alien X movement. Now that could sound a bit confusing. If you go to the blog, which is linked below, we're going to a bit of, well, not a bit of detail, but we explain more fully what negating this means. But basically, if the movement amount was 2 pixels at a time, then, and we're going to the right, then if we're adding 2 on at a time, must be going to the right. So alien X movement amount will equal minus 2. So that will then become minus 2. So that means we'll end up going to the left then if we're taking away 2 each time. If we actually then get to the left, so it's already minus 2. So if we go alien movement amount equals minus 2, it'll make it back to positive 2. And that's how we manage to reverse the direction. And then we set a little flag saying, yeah, we've dropped a line at the edge, we need to drop. And then we go around updating all those positions, which is what this bit of code here is doing. Again, we'll look through all the invaders. We see whether they're active or not. If they're not active, they've been destroyed. There's absolutely no point in updating their position, so we don't. Only if they're active do we bother. If we're dropping, if we're not dropping, so if we're not dropping, which is there, if dropped equals false, then we're actually moving along the screen. So we add whatever the X amount is, whether it's a 2 or a minus 2 or whatever it might be, we add that amount to the X position of this particular alien. If we are dropping, which is here, then we will actually just increase the Y by the drop amount, which I think we said was set to 4. So that updates all the alien positions. And then we get the invaders move counter, we reset that. So you remember up here, if it's gone in here, it must have gone from 12, 11, 10, 9, 8, etc. Drop below 0, then we've come in, done all this work to here. We then need to reset that back to the original start speed, and it can do a whole 12 cycles before it comes into this routine again. And then here we go, we toggle the animation frame. So the animation frame will go from if it's false, it'll then end up being true. If it's true, it'll end up being false. But basically, we'll display the other animation frame. So moving on. So we've got the rightmost position and leftmost position, which said here is going to get the rightmost position of an alien or the leftmost position of the leftmost alien. So we'll have a look at the left. So we've got the rightmost position there. You can look at that in the source code on the blog if you want to, but we'll just talk about the leftmost position for now. So basically it's going through not every alien actually, potentially it could go through every alien, but we're going to go across in columns. So we're looking for the leftmost positioned alien. So we're going to set across to 0. We're going to start on the leftmost column. So if I bring up that screen we had before about the aliens, okay, let's bring that up. There we go. So if we bring that up, the leftmost column, we're going to go down that leftmost column a row at a time, and if they're active, so we'll just flip back to the screen. So we're going to go, look, we're going to go across at 0, then we're going to go down each one of those. If it's active, it's not been destroyed, we then say, is it smaller, is its X position less than the smallest X position so far? Well, we purposely set smallest to a massive amount here, which would be twice the screen size, so no X position of alien is going to be that. So we set that there. If it's less, then that becomes the new smallest amount. Smallest will be that particular alien's X position. And then it'll repeat for the next one down and the next one until it then comes out. So imagine this is still in the first column. Just bring that back up for you. Okay, you can see it's still on the first column. We've gone from 0 to 1 to 2, and imagine the first two might be destroyed perhaps, and we've got the third one left, and it checks that position. Went back to the code. If the smallest is less than that, it means we've set the smallest. This is what the initial smallest was set to up here in this line. If this is now less than that, then we have found the alien that's got the smallest X position, because we've done it on that first column, and we're going to go from the first column alongwards. Let's bring that screen back up again. So we're going to go from this column, and imagine if they were all destroyed, then we go to the next column and the next column. But either way, it's going to be one of these columns. If it's the smallest, if we get a live alien that is the smallest X, all the others must be bigger than that, because they're further that way. So I'll come back to the code. So if we've actually set the smallest, when we've found the smallest basically, and we'll come out of this routine and return smallest. So that gets the leftmost position. The rightmost position is extremely similar, except we have to, if you look at this line, the rightmost position is basically the X plus the alien width in order to get the right hand side of the alien. And that's about the only difference really in those two bits of code. Looking at the update display, that's a little bit different. So you can see for each bitmap we had before, we just had case 0, case 1, and then default, which is basically row 0, row 1, row 2, the 3 rows we've got, and we drew the bitmap either the top, the middle, or the bottom. This time for each one of those rows, we're looking at the animation frame. If it's true, we do that one. If that would be false, then we're going to go in to this line here, and we're going to display that other alternative, the second frame of the animation for either the top invader, or the middle, or the bottom. And so every other walk or positional move that the invaders make, we get a different animation graphic. That is actually a very quick walkthrough of that. If you want to get a bit more detail, as I say, look down below, you'll see a link to the blog post. That's all there. It shows you the source code, what you can copy and put into your own project, which you can then work on maybe for looking at what we're going to do next. It'll explain a little bit more in some depth about the let's just scroll back up here. Where was it? Sorry, it's gone too far. Explain a little bit more about these minus numbers here, with a few examples if you're not that secure on that area of having a minus number and how that works. So I'll go into a little more detail there. It'll talk about the code in a more textual form, obviously, because it's a blog, and some people find that easier to work with. Anyway, in the next episode we're going to look at actually bringing a player tank on the screen, and we'll add a couple of buttons to our hardware so we can control that player tank, so we can go right and make it go left. Until next time, like and subscribe, and bye for now.